Welcome back to another episode of Iron Culture, folks, presented by Mass. And of the Mass team, we have a slightly different cast of characters. I am the only Eric on this podcast, so fortunately, that's good news. Unfortunately, though, I am joined by none other than Dr. Michael C. Zourdos, MCZ, as you will see his acronym when he is discussed in the acknowledgments for supposedly doing something on a paper that may or may not have occurred. But thanks for hosting with me on this one, buddy.
Yeah, I mean, I think really it's your hosting with me, as I'd like to frame it. You're also outnumbered 2 mics to 1 today, so a little more reverence for the name would be appreciated. As you give me the intro there. But I'm happy to be here, and we're here today with someone that I highly admire and respect, so I'm excited about it.
Yeah, this is true. We have 2 Michaels, 2 Dr. Michaels. We have Dr. Mike Ormsbee from FSU. So welcome to the show. Please give a warm hello and welcome to Dr. Ormsbee.
Welcome, sir. Eric, with Dr. Mike Ormsbee being on here today, I don't know if our audience knows who he is, but before we get into that, I easily could have told him this off the air, but I chose deliberately not to. Let me say, before I bring up this, my friend, Dr. Ormsbee, as I'm looking at you now, you suffer from this same issue. So I got a chance to see Dr. Ormsbee right about a month ago. We had a meeting, Eric, you and I, and the rest of the Mass crew. Not long after that, you didn't know it. I was half incapacitated at the time. It was a rough day for me. But when I saw him, I don't know when the last time we saw each other. Maybe 2016-ish or so. I think Wow. It came up to one of my former students, master students, dissertation defense. Now Dr. Alex Klemp, and I believe I got to see you then. And when I saw Dr. Ormsbee after all this time, I am now an old, broken down 39-year-old man. First thing he says, we go to give him a handshake, give him a hug, and he just starts laughing. He goes, "Look at all the gray in your beard," and I'm not denying the existence of this. First of all, I was honored that he even called what I currently have.
Well, I mean, come on, take a look here, guys.
But I'm looking at you, man, and I just want to know. I feel that if I were to rate the grayness, it'd be slightly more on your end.
It should be though, right? It should be. I'm going to take it because I get these little wisdom hairs in, man. My kids make fun of me all the time.
Okay, wisdom hairs. I'm writing that down. So I don't know if you know this, Dr. Ormsbee, but there is not a peer review month that goes by in the hollowed halls of the Google Documents and the private Mass group where there is not some snipe, jibe, or joke, to put it nicely, about my age. And any opportunity, see, there you go. Any opportunity that is there is exploited. And one of the reasons why I shave my beard is specifically because I want to not have 10 minutes of banter every time I see Mike about said wisdom hairs, which I like and I will write down. And as a side note, I'm definitely going to have to shave before the 4 of us, the whole Mass team, meets out in Austin, Texas on April 12th and 13th. For the first time, all of us will actually be physically together. We are presenting at the Sports Nutrition Association Conference in Austin, Texas, the annual conference, and also having some team meetings. So please do check us out. If you ever want to see us do our thing live, I can tell you that Dr. Zourdos, to be serious for a moment, one of the best in-person presenters in the game. Excellent lecturer, excellent teacher, and something that has definitely always impressed me about you. Other skills definitely suffered to give him that ability. Basic life skills, communication skills, emotional intelligence, but you don't have to deal with any of that if you just come out to Austin, Texas, see us there, see him present. And for all those who are interested in supporting Mass more broadly, please like, rate the show, If you really want to help us do this work that we put out there for free and give us a nice subscription, and we promise you won't be disappointed, to the Mass Research Review. And I promise I am now done segueing from beards to selling. Back to you, Dr. Zourdos. Let's give a little more of an introduction of who Dr. Mike Ormsbee is and what his expertise is and why we're so excited to have him on the podcast.
Yeah, it's really an honor to have Dr. Ormsbee here. And so I've had the pleasure of knowing Dr. Ormsbee now since, I believe, either 2009 or 2010. Mike would know because whatever that first year is, he started at Florida State. Way back when, as an assistant professor, he has moved up the ranks to a full professor. So Mike is a full professor at Florida State University. He is a federally funded researcher at a big-time Research One university, which, let me tell you, folks, is not an easy thing to do. He's also the director of the Institute of Sports Science and Medicine, the ISSM, at Florida State University. I had a chance to see the facility recently, and he has just done such a wonderful job growing this facility since its inception now, many years ago at Florida State University. He has mentored many PhD and many master's students, including being on my dissertation committee. He even told me the morning of my dissertation, he may not remember this, when you get up there, you should tell them, welcome to my offense instead of my defense. And I said, I'm not going to do that, but that is hilarious. But Dr. Ormsbee is a wonderful mentor, wonderful scholar, published many, many papers in his career, and continues to do wonderful work to this day. He has publications on resistance training and fat oxidation, pre-sleep protein. He's done some resistance training work, done some multi-ingredient supplement work, pre-workout supplements that he's tested, has brought in a lot of external funding. So Mike, I'm sure you can add to that, but that is the background, and you're dealing with a real scientist today, folks, who has accomplished quite a lot in the field of exercise physiology. So while we talk a bit in jest at the start, everything I just said is very true, and it's a person I admire and respect a great deal, and is a mentor to me. So Dr. Ormsbee, thank you for joining us.
Thank you, Michael. Appreciate being here, man. It's fun to, I tell everybody all the time, it's like when you see your former students just doing really well, it's a total highlight. So I love seeing what you're doing, Mike, and what you've accomplished here in your, both of your sort of work lives and your professional, your actual personal life. So I'm happy to be here, man. I love to talk shop because I don't get this opportunity often. And it's maybe a chance to talk about things that your audience could be interested in, several different lanes, and we'll see where you guys want to take it.
Absolutely. I think one thing that I was really interested to hear more about is specifically, as Dr. Zourdos mentioned, fat oxidation during resistance training. So I think if you were to talk to the typical, even quite well-educated person in the resistance training space, and you ask them about energy systems, they'll be able to give you kind of the typical answers about, okay, first we're just going to use a little bit of that stored ATP for our most high-intensity contractions in the first 4 seconds, and then, okay, we can recycle that pretty quickly for high-intensity stuff, but not super high efficiency with the phosphocreatine system, and then we're tapping into glycolysis, and after that, we're probably not in the resistance training realm anymore. We're doing other things. And then if you get a little more savvy of a person, they're like, well, all of our energy systems are going on all the time. During your rest interval, you're recovering, they're working in concert. But I think a lot of people would be surprised by some of the research that has been done in this area over the years. I remember the first time I came across a paper from, I want to say, the late 90s. I think the senior author was Tesh, if I recall. I was pretty surprised to see that a typical bodybuilding workout resulted in substantial depletion of intramuscular triglyceride. And I was like, oh, what's going on here? And it, as a young person who was still kind of learning some of the concepts I just explained, it challenged a lot of the assumptions I had, and it helped me have a better understanding of fuel utilization in a more holistic manner of resistance training. So I guess where I think we should start with this is, Dr. Ormsbee, if you could help us have a better understanding of what is going on with fuel utilization during resistance training. Is it relevant? And specifically, are people aware of how, fat is essentially used, despite what maybe our presumptions are when we're talking about lifting weights?
Yeah, one of the things that's interesting with resistance training is almost everybody talks about it from the angle of hypertrophy, muscle growth, strength development. I mean, there's a lot to keep learning, but there's a lot known in that space. And one of the things I think we pride ourselves on, things we've been interested in, is we've always looked at it from the other side of the body composition equation. And so, I think it's really fun. That's why we've been successful with some of our funding, is looking at resistance training specifically as a tool for fat metabolism and fat oxidation, ultimately to, better impact body composition. And what I've learned over like 20 years of this is, and we can weave the story of that, but as we watched the history of it, it's funny because we sort of knew the outcome originally, like what we saw in the data were losses in fat mass. And now we're sort of working backwards to figure out why and how. And the other piece I think your audience will find fascinating is now we know just recently that we have more communication between the muscle and the fat than we ever thought possible. And there's probably something to growing the muscle, which then also speaks to the fat and actually induces fat metabolism. So if we kind of look historically, you're right. There were early studies back then. They were looking at fuel use during a bodybuilding type of exercise. And even beyond that, one of the things most people lean on heavily is energy expenditure. And so there were those early studies. I don't know if you remember those from Chris Melby's group and Schwenke's group. And they were looking at, one session, how long does energy expenditure stay elevated? And, they were looking 48 hours, like 2 days after training. And they saw, in terms of like milliliters of oxygen per minute, there was an elevation. And so it was like, okay, so there's something's going on here. And then follow-up studies were showing 48 hours, you still have this increase in VO2 max, or VO2 utilization, but it's transient. And what happens when you start eating? And it just showed something was going on that I think we leaned too heavily on for about 2 decades, where muscle mass would increase energy expenditure, and sort of that was the mechanism. And so, we looked at it deeper, and some of our original work was like, I was seeing papers come out on aerobic exercise and specifically fat metabolism. And the techniques that are used are pretty cool. We started using those here so we could look at, microdialysis, for example, where we could put probes into specific tissues. That we usually use the subcutaneous abdominal adipose tissue. Sometimes we use the glute tissue or femoral, but you can put these probe in any tissue in which you can find a place to put a needle. And you can insert that. So we have done it in skeletal muscle. We have done it in calves. We've done it in Achilles. We've put it in all sorts of places. But in my lab, we pretty much use the sub-Q fat in the belly and also in the glutes. And we actually have some ongoing studies in that space now. But sort of to back up a little bit, the reasons that we thought this could be useful is that energy expenditure is high. And then there was a 83, maybe 84 study that looked at Nautilus versus walking. It was like the old Nautilus studies from way back when. And they were looking at a circuit training Nautilus workout, all weights, and against walking at 4 miles per hour. And they simply measured the norepi and epi response. So you're looking at the catecholamine response to resistance training versus walking. And they were several fold higher from doing the Nautilus workout as opposed to the walking workout. Well, we know the catecholamines are lipolytic. In many cases, in the right sort of, let me rephrase that, sort of in the right nutritional environment, they're lipolytic. And when we saw that, we're like, okay, so it looks like from energy expenditure and the ability to mobilize and produce some hormones that could be responsible for this, we're like, all right, so those things kind of line up. The other piece to this is growth hormone. So you guys are well versed in this, right? We pretty much have debunked that a short-term increase in growth hormone does anything for muscle, but it does something for fat. And that's where I think the conversation, it gets dismissed every time. Oh, these transient hormones didn't do anything for muscle. Don't think about it. But I think it's working in the lipolytic side of the equation. And so there's some evidence for it. There were some good studies looking at I think there were 3 to 5 sets of 10 reps, like with this little 1 minute pull down. It was kind of a full body. I think it was like lap, shoulder press, some knee extensions, and kind of a real basic workout. But over 30 minutes post exercise, you saw growth hormone keep rising acutely. So over 30 minutes post exercise. And so that lipolytic thing could be the angle or for the reason for which, growth hormone is increasing. And so I thought that's kind of the neat angle. What happens if you inject growth hormone And we can do this through microdialysis probes where you perfuse it directly into the tissue you want. And so there was a study in 1999 that perfused growth hormone directly into the adipose tissue. And when they did that, they saw a massive increase in glycerol liberated from the fat cells. And so now it's like, okay, we see it rising in just normal blood draws. And then we also see if you perfuse it, you get directly into the fat area cells, you get an increase in glycerol, which is, we measure glycerol because it's stable, right? So glycerol can go on to, basically put into glucose or used for other fuels, but you can't go back into the fat cell because it lacks that glycerol kinase enzyme. And so it's stable when we measure it in that environment. So like, all right, from these types of things, I feel like resistance training should be a great promoter of lipolysis. And so those studies in the early 2000s basically wrapped up, and people leaned on energy expenditure for like 20 years, or maybe 15 years, that was what was happening here. And then sort of simultaneously, we started seeing real life application of this. So you probably have seen like of many different studies that are showing resistance training and then looking at body composition as an outcome. And you see typically a gain in muscle or a loss in fat. And the only thing people talk about typically is, oh, body comp improved, and here's how much muscle you grew, and here's how much muscle this, and muscle did that, and your bench press did this, and your squat did that. I'm like, well, let's look at the fat side of that. What's actually going on? And so I was fortunate to team up on some research that was looking at resistance training as a dominant part of a protocol versus the recommendation just to like basically get as much moderate intensity walking or running as you can. And we sort of compared these or many other variables, but that was the crux of what was driving this. And no matter what, exercise was a win in terms of fat metabolism and fat use in the visceral and in the sub-Q. And resistance, the group that incorporated resistance training always had better outcomes. And the outcomes were just better. So it's like, all right, theoretically, it should be doing something. When you look at applied outcomes, like the actual thing people want from a protocol, that was happening. And so we had done a series of those studies. I did a lot of this with Paul Arciero from Skidmore College, and he was leading that effort. And we did some like multimodal studies where you were giving resistance exercise was part of it, but we also prescribed like interval training, stretching, and yoga, and some endurance, like slow endurance running as well. Every one of those, the fat piece of that was improved with the addition of resistance training. And so we're like, all right, this all looks pretty darn good. And then one that like we said, this is just too good to be true. And then I was like a doctoral student looking at some of this information. I was like, all right, but how is it doing it? What is the actual thing mobilizing these fuels, right? So in that story of this, I was looking at this aerobic exercise, and we knew that exercise would sort of stimulate the lipolytic response by either activating the beta receptors on the fat cell, but on some occasions it would actually activate the brake on the fat cell, which is the alpha receptor in the fat cell. So we're like, well, all right, we have this technique to get drugs directly into the fat cells. Can we just block or activate these different receptors and figure out why? And so we took advantage of that technique, and we started looking at the endurance exercise first. And one of the tools that sort of came from that was where we saw that in endurance exercise, if you did a cycle of training, you saw an increase in the glycerol coming out of the fat cells. We're like, let's just do that with resistance training and figure out, is that a thing that sort of actually works for us? And when we did it, we had significant increases in the glycerol response as an immediate result on that exercise, about resistance training, circuit training kind of about. And that set us on this journey, man. I think that our work in that space sort of led the way to several others. We started this work in young men, as you do. Over the years, we've repeated that study in women. And then we've also done it in different phenotypes. So people who suffer from overweight and obesity, and also people who are lean and fit. And so kind of piecing all of this information together, we ended up with a paradigm where only a few things were showing us what was happening. The catecholamines are increased, and they look like they're more increased than you would see from an aerobic training session. We've never compared it to HIIT or anything, so there's that caveat. Growth hormone is significantly elevated in these studies and immediately, and that's probably driving this lipolytic response. And notably, we've never measured other things that could be lipolytic. So like atrionatriuretic peptide, for example, lipolytic, we have never measured it. And we always say, like, we should, in the next study, we'll measure AMP. We just, unfortunately, like, I don't know how much it moves the needle, but we've never measured it, and I'd like to. And I think the cool thing, maybe for a discussion piece, is like, I do lean versus people with obesity have different outcomes, because there are different outcomes, and we've looked at a lot of that. And then why don't we ever pit this stuff against each other? And that's actually our current grant now that we have, that's our NIH grant, is looking at directly comparing resistance to endurance exercise. And let me tell you, that is extremely difficult to do. Almost every other study that's done it has done it on time. So you just work out for an hour or 45 minutes or whatever it is. And because of that, you have an advantage for aerobic exercise. You're just going to burn more calories in that type of a session. What we're doing is we're matching calories. It is extremely difficult to do. We've been doing it for 4 years now. And we have to go around with the metabolic cart, and the resistance training session is longer than the other session, but we're matching for calorie expenditure. So we're throwing everything at it, guys. We're doing like hyperinsulinemic euglycemic class. We're doing tracers. We're doing biopsies. We're doing microdialysis. We're doing deuterated water. We're like doing every single thing we can to get some answers for what's happening. Should we be promoting resistance training as a first line instead of maybe a second or third in recommendations for fat loss specifically? And yeah, it's kind of an interesting study that we're using postmenopausal women. So now we have other sort of factors in play. But yeah, it's really interesting to me that I think resistance training is fat loss training, and I don't think it's promoted that way.
Yeah. So there's two things I have for you, Mike. Well, I guess first, let me say, I really do think this is fascinating, because just the ending statement there of resistance training really is fat loss training, right? That's going to run so counterintuitive to what most people think, right? I need to lose weight. The common individual, hey, I need to go outside and walk. I need to get on the treadmill. And that's fantastic. If they're not doing anything, please go do that, right? But to say resistance training is fat loss training is really kind of shifting that narrative a little bit. And so I had a question for you while you were talking there, when you were talking about how you match up the aerobic training and the resistance training sessions you're matching for calories. And there's no doubt for everyone listening, this is extraordinarily difficult. We did a concurrent training study years ago in our lab. And as Dr. Ormsbee said, it was time equated concurrent training. So we had resistance training groups, then those that were incorporating either steady state aerobic exercise, HIIT, or a resistance training circuit. We equated it for time. It's just simply far easier to do. You don't have to be mobile with the metabolic cart doing that. So the fact that you're equating for calories is excellent. But given the fact that lactate can inhibit lipolysis, right? And so lipolysis is we're breaking down triglycerides into glycerol. And so if lactate is inhibiting that process of ultimately breaking down those triglycerides, when you're equating these stimuli, are you designing the aerobic exercise in a way where it's more moderate or low intensity and there's not a lot of lactate buildup and you're not affecting lipolysis as much? Or are you designing the resistance training conversely, where there's short rest intervals and let's say you are going to increase blood lactate above where it would normally be? Is that something you're taking into account given its downstream effect on lipolysis and triglycerides and glycerol?
Yeah, it's a really good question, Mike. The short answer is no, not really, but it's sort of embedded in the protocol. So we have the aerobic group is quite low intensity. You know, again, the group we're using are postmenopausal women that are overweight or obese. So we have some and sedentary. So we've got some limitations on what we can actually get done, but they're great, man. They work so hard, and they're just such competitors. It's really cool to watch how they grow over the course of this in terms of their training and what they want to do. But so, well, lactate is certainly involved. I mean, even in that early Nautilus study, they looked at lactate and the catecholamines, and they all significantly increased. But even despite that significant increase in lactate, the catecholamines probably overrode the lactate response to initiate lipolysis instead of break it. And so because we're not doing this system in a dish with just a brake or just an accelerator, it looks like, and I don't know if we have data on it for sure, but it certainly looks like the catecholamines are overriding that lactate response to induce or inhibit a lipolytic response.
And it's a complex milieu of what goes on when you exercise, because what also concurrently rises with lactate is growth hormone, So I think that's one of those interesting things with physiology is you learn typically when you're taking, I would say even your graduate level physiology classes, you learn a fraction of what the actual roles of these molecules or hormones or neuroendocrine responses do. And even then, if you did get the full picture, if you were to all right, yeah, I'm sure I've got my graduate, class with my instructor, I'm going to then go ahead and actually just dive into the research and read every single thing. You come to learn that we probably know about 20% of all the function of these things. So I think it's a really fascinating question as well.
Yeah, what's neat is 100% that is the case. And you guys know kind of the longer you're in it, the more you're I don't know, there's so much to this. We know our one little slice and somebody knows it 10 times better than I do somewhere else. It's interesting how that works out. But in this study we're talking about, one of the things that's neat is that we're trying to, in addition to just the training, they do these giant laboratory days before and after the 12 weeks of training. And on one of those days, they either get a hyperinsulinic euglycemic clamp to initiate lipolysis, or the other side of them, they walk on a treadmill for an hour to induce the lipolytic response. And in both cases, we're measuring glycerol, glucose, and lactate directly from the tissue, and 3 microanalysis probes in the abdomen, 3 more in the top of the glute, and 1 in the thigh. And so we have a ton of things going on where maybe we'll be able to answer some of these questions. And the reason we have them walking is to induce the lipolytic response, but we also get to see what did the previous 12 weeks of training do to the response of your catecholamines, and in this case lactate, to a bout of exercise that's more ambulatory, just walking around. How do we get from here to there, which is what a lot of the things we're trying to see is can we increase if you're just walking, are we improving the ability to use fats as a fuel from the training you're doing? So there's a lot of questions sort of mixed into all this. And one of them that you guys might be interested in is what is the energetic cost of resistance training? And does it matter if you're a young, fit person, which is the only place we have any data, versus this group who are overweight, obese, postmenopausal women? And so, we're trying to do those and put out side sort of papers on this because we have so much data on the energy expenditure of these population burns from this resistance training protocol. So I think we'll have hopefully some papers coming out in the next 6 months to a year that are explaining what we're seeing in terms of energetic costs, which is a little bit lower than the data that exists in younger men.
Yeah, it got me thinking, Mike. I was gonna kind of ask you this the first go around, but you mentioned, can just walking, make you more efficient as using fat as fuel, right? And that's what we hear with aerobic exercise all the time, right? Whether somebody's, going at a moderate intensity to zone 1 or a zone 2 kind of aerobic exercise, right? But what I always try to kind of impress upon folks there is, and I would imagine you would agree, but maybe you don't. And I like to see your explanation of this. Would fat burning be the same as fat loss, right? Because oftentimes what we see in these fat burning zones, if somebody's in, with aerobic exercise zone 2, and just really this more moderate intensity exercise, as you said, right, resistance training may be more fit for something like this. So fat burning isn't really synonymous with fat loss, is it?
No, definitely not. There's going to be a big change there. And, I think some of the things you have to remember are we're also looking at this in a case that's hyper-controlled. You throw in normal eating patterns, what's going on with sleep, what's going on with your other macronutrients and fiber intake, what's going on with your stress levels. Like, so many things will play a role in all of this, but like you're talking about the old school, you go and you hit the button that tells you on the treadmill, you're in fat burning zone, and you're not expending enough calories to really make any kind of a dent. At the end of the day, if we're talking about fat loss, you got to be controlling calories, and that's got to be like the crux of it. This is just a tool that helps us get somebody there. And so we did this study, and this study, Mike, because this was from Eddie Joe, and Eddie Joe's dissertation, and that Dr. Kim and I are working. So the late Dr. Kim was Mike's PhD advisor and Eddie Joe's PhD advisor. And I was interested in working with these guys on this study because it was right in our wheelhouse. And to this day, I still think it's one of the most, it's one of the studies that I think deserves the most attention and doesn't get any. And I'm going to explain it because it's really cool. So these people that are going in for bariatric surgery, so they're all at that time, we called it morbid obesity. You don't call it that anymore. So, but they had a lot of excess body fat, and they were coming in to get surgery. And instead they see Eddie and his team in there, and they decide to try to recruit these folks into a resistance training study. And this is interesting, but those people are medically prescribed a diet that is only about 800 calories. And they're coming off of like a calorie load that's clearly not working for them. And that's such a huge difference, one. And it's primarily a liquid diet, which is crazy. And it's also, when we did grams per kg of protein, and they have a high kg body mass, they are something like 0.4 to 0.55 grams per kg, which is like half of the RDA, which is like probably half of what we probably should be aiming for or less. And anyway, so they're in this routine where it's pretty bad. 800 calories is pretty bad. What we decided to do, or Eddie decided to do, was put on an extra protein bolus. And so he got everybody up to, I think it was like 11 or 1200 calories just to have a little bit more protein in the diet. And then one group got the resistance training program for 12 weeks. And then one group got like the normal prescription, which was like calisthenics and walking and things like that. And the coolest part was that at the end of that study, they had a very similar amount of weight loss, which was tremendous because they were not eating very much. But the group who included resistance training lost, of the weight loss, 96% of it was fat and 4% of it was muscle.
Mm-hmm.
In the group that did not do resistance training, 25% of their weight loss was fat and 25% of it was muscle. So to me, like, that is such a stark contrast, and something that should be really promoted is that if you're attempting to lose massive amounts of weight, resistance training should be absolutely essential to what you're trying to do in terms of an exercise training protocol to save your muscle and to ramp up your ability to use fat as fuel during that particular period of time.
Man, I've got so much to say right now, and I'll try to constrain it. This is good stuff. I'm really excited about this topic. I was digging into the research specifically on this topic, and I was trying to explain how things vary so much in different populations as far as body composition change following an energy deficit, depending upon quality of resistance training, experience with resistance training, and baseline body composition. And there was a pretty cool meta-regression that came out a couple years ago by Murphy and Kohler. And if you look at their regression, you can see a really clear line, if you ignore all the dots around it, that says, hey, right around 500 calorie deficit is where we see no change in lean mass. But when you look at the dispersion of those dots and you think about the heterogeneity and how much is explained by that relationship, and you start to look at some of the individual studies, there are studies, to your point, where people with obesity are consuming 1,100, 1,200 calorie diets and actually increasing lean mass in some cases when they are naive to resistance training. And then you've got studies where people are on smaller deficits, but they are extremely lean. Some of the bodybuilding case studies and case series that are out there, more predominantly in men, and there is still lean mass losses. And when you go all the way back to look at some of the substrate utilization, when you compare people with obesity versus people with who are quite lean and during total starvation, you see multifold increases in the use of, say, leucine as fuel or gluconeogenesis and converting amino acids to other substrates in lean individuals. And the more recent work that's come out of, say, Dr. Stu Phillips' lab, looking at muscle protein synthesis, you see when you're in a deficit, it suppresses muscle protein synthesis. But when you're lean and in a deficit, muscle protein breakdown also goes up, just kind of showing how much more we start to rely on our endogenous stores of amino acids for energy. And I think that's really interesting. But another really, really interesting piece, I was digging into trying to figure out the early roots of the 3,500 calorie rule. And I don't know if you guys have ever looked at the original papers. You have to dig into like Hall citing somebody in the 80s, and they cite a paper going all the way back to, I want to say, 1958 by Wisnowski, or 1956. The Wisnowski rule is actually the 3,500 calorie rule, which is just him going, okay, so adipose tissue is close to 90% actual fat, and there's, actually, we say 9 calories per gram of fat when we talk about counting macros, but it's closer to 9.4, 9.5. You do the math, boom. It's, 7,700-ish average. But the difference between that and what is the actual metabolizable energy from fat mass is different. And I was digging into this because I was also trying to figure out what is the energy cost of building muscle and how much metabolizable energy is in lean tissue. And there's a pretty big disparity between the surplus that you intend to put someone into and the amount of lean mass gains you see. And one of the reason I bring this up, that was a long intro, is that I think one of the most powerful fat loss tools that resistance training provides may not be during the exercise itself, and you may not agree with this considering you're the one who's actually looking at these acute responses, but the process of building muscle is, I think, very energetically demanding. And it's quite interesting because when you think about it, you put someone in an acute energy deficit, muscle protein synthesis drops. So it's an energetically demanding process to build new tissue. And when you do the math, there's only like 1,800 calories-ish contained in a kilogram of lean tissue. That's like a fifth of what's in adipose tissue. So technically, how large should your surplus be if we're thinking the same way we think about fat loss? Oh, let's drop 500 calories. I'll lose a pound a week, or roughly half a kilogram. I only need to up my calories 100 per week to see half a kilogram of lean mass gains. But that's not what happens, at least predicting what we think in, say, novices or resistance trained naive individuals. They generally have to increase their calories a lot more. And there's more going on than the cost of building muscle tissue. We see that NEAT can go up in some people versus others. Obviously people are just bad at tracking their caloric intake and estimating things. But I always kind of view it as not only is resistance training important to the point you made, that it preserves muscle mass so that you got to use something else to cover that energy gap. But I think some of that, like 48-hour energy expenditure, it could be some of the muscle damage that's being repaired, especially in these one-off studies with untrained individuals. But I think in people who are actually growing muscle, I think the process of building new tissue is pretty expensive long-term. And I think that's almost like this caloric drive that results in, fat loss along that process over the days afterwards. At least that's what it seems like. An interesting anecdote. In the world of IFBB enhanced professional bodybuilding, a common thing that kind of the new wave of highly enhanced, like professional guys who are on stage at my height, 50 kilos heavier than me, not that I'm exaggerating, but a lot heavier than me. What they often do is they'll ramp up their drug protocol going into the show, and their calories come up, and they may be in a deficit or maybe around maintenance, but they're building muscle so quickly that they're getting leaner at the same body weight. And sometimes you think, oh, that's breaking the laws of thermodynamics, but when you actually do the math and you think about it, it's like, well, like if you don't provide enough energy to, like, from exogenous fuel sources to support this muscle growth, but it's going to happen because you're literally conducting, chemical warfare on yourself. It's got to come from somewhere. And you're seeing these guys suck down and get leaner while growing tissue. and they're in these, they're gaining a small net amount of weight, but because of the energy density of fat tissue versus lean tissue, they're probably still in a deficit. But it's just really interesting. So I would love to hear, what are your thoughts on potentially, is it the acute things that are happening in the weight room, when people are lifting weights, that you think is driving some of this unexpectedly high fat loss, making it a useful tool? Or do you think it is the actual process of building muscle driving more fat loss in intervening days between measurements? Is it more the longitudinal, the acute, both? What are your thoughts?
Yeah, thanks for that background, man. Like it's amazing to see sort of the nuances of this. And when you look at it that closely, it's gosh, it gets confusing quickly. And that is something that I think, even if you're well versed in this stuff, I'm like, oh God, it's probably a combination of both, because there are so many things at work. But I'll tell you this is really cool. In 2014, there was a paper that was looking at myokines and cytokines initiate lipolysis coming from muscle, speaking to adipose. So the process of training and creating these myokines that leak into the blood and circulation, maybe that's the piece that's driving the lipolytic part that then drops the fat loss even more and saves the muscle. So that is one angle that we have never dug into, but we have blood. And I'm like, man, we should go back and look at some of this stuff, because we're sitting on, biobanks sometimes where you've got samples stored. It's like, well, maybe we should go look at that. And those old studies I was talking about, like we just were blaming it on GH, insulin too, in the people with obesity, they had higher insulin all times. So that was a problem. And then some of the catecholamines. But the other thing, one of the coolest papers I've read in a while was, Vichetti's paper in FASIB in 2021, and they were looking at basically mechanical overload in animals, and they were able to show that this protein called MIR1 was in human muscle, or in a culture model, was decreased, and it was coming into the plasma. And when that happened, the MIR1 is a brake for lipolysis. So essentially, MIR1's leaving the adipose, going to the muscle, stopping the brake, and increasing lipolysis in that adipose tissue. So it's multifactorial. I think we're working with what we traditionally started with, higher energy expenditure. You're adding more muscle, so maybe that's more energetically costly, and we want to be inefficient as possible in this case. And then we're seeing a high, growth hormones high, all things that are lipolytic. And then maybe myokines, cytokines are SOAR. That's also stimulating lipolysis. And then perhaps this other mechanism, which is basically only in animals so far, but if they show in humans, that would be neat. And then you have this sort of 6-pronged approach to resistance training, making sure that fat loss is happening.
You muted, Mike. This is why I don't let my host.
Listen. This is the start for everybody out there. Next time we're going to have just me and Trex. After that, it's going to be just me. And then finally, the end result is just me and Lauren. And we're getting the I don't know how the appropriate way to say it. The Erics, maybe just an Eric, I don't know. Whatever it is, it doesn't really matter. Out of the way, we're pushing them out. They're no longer here. And, Lauren and I are taking over. There was one episode of the now defunct, but kind of still here, somewhat merged podcast where it was just Lauren and I, and then Helms jumped on like 30 minutes late, and we tried to ignore him. And that still stands alone as the best episode in the lore of mass / presented by mass iron culture, whatever we call it. I'm not sure. So we'll get back to that good time. Now, Mike, I think I'm familiar with the paper you're talking about where you mentioned from 2014 the myokines initiating lipolysis and having the potential to improve fat mass. I think that's from a South Korean group, if I'm remembering that correctly. and they looked at a lot of different myokines, right? So not just the typical ones that we would think of here in kind of the resistance training world, but things like interleukin 15, which is known to have beneficial effects for muscle hypertrophy, then potentially leading to decreased fat mass. Other even neurotrophins like BDNF or brain-derived neurotrophic factor, right? A potential mechanism here would be, if I'm getting this right, BDNF would aim to act on AMPK and increase fat oxidation. Fibroblast growth factors, which there are a few of. I think that paper looked at FGF21 specifically, which also seems to have some interaction with BDNF, which would increase glucose uptake. There's a leukemia inhibitory factor, which I think would be involved as well, potentially. And I think leukemia inhibitory factor, what we see as LIF, is something that would act on to regenerate muscle as well, which would go into that energy expenditure cost. So just the point is that this is really multifaceted. And when you mentioned growth hormone earlier, this is kind of what I started to think about, because I first got interested maybe over a decade ago now, maybe 12, 13 years ago, in BDNF or brain-derived neurotrophic factor. And the early studies in that tended to suggest that with aerobic exercise, when there was an increase in blood lactate, there was a greater increase in BDNF. And everybody was pointing to the fact that the acidic conditions in the blood lactate increase is what was causing the BDNF response. But we now know that's not the case. BDNF can increase independently of that. They may both increase at the same time, but there's not a causative relationship. So we can't say if it's growth hormone or if it's IL-15 or if it's FGF21 or if it's BDNF or if it's leukemia inhibitory factor. It's difficult to know, or if it's a combination of those. If I think about the myriad of responses that all of those different myokines have, whether it's muscle regeneration, whether it's specifically directly related to hypertrophy and some of the downstream pathways in the case of interleukin 15, whether it's BDNF acting on AMPK, it could be multifaceted. It could be an interaction between those. We're not entirely sure, but I think the point is that your point is really good regarding, hey, we know that growth hormone is doing this. Is that what's driving it, right? Just as we used to have this hormone hypothesis with resistance training, right? The acute increase in growth hormone potentially is or what was said years ago was the causative factor in muscle hypertrophy. But now we know that
I used to say it, or I used to teach it.
Yeah, I did too.
I talk it back.
I didn't.
I'm sure you do the same. I tell my students all the time now, which I didn't do in 2012, really, when I started out, because I definitely I had an inflated sense of what I knew at that point. But I tell my students all the time.
It was that dissertation defense, I remember.
You remember all too well. All too well. I'm sure some of your colleagues and my other mentors at FSU remember all too well when there was a time, and they let me know, and rightfully so, and I'm much better for it. But I tell my students all the time, unfortunately, something that I'm going to teach you this semester is wrong. I just don't know it yet. I don't know what that is. If I knew it was wrong now, I wouldn't tell you, but it's going to be wrong at some point. I remember the first time I taught the sports nutrition class here, I would talk about the importance of protein timing immediately following training. And it's not that it's completely unimportant, but it's not something we have to really, structure our whole day or whole life around, especially for most folks to ensure, hey, we got to get this shake immediately right after, right? We know protein timing can maybe have a small effect, but it's not what we need to structure everything around. So we know that growth hormone hypothesis for resistance training isn't how we have to structure our program to maximize muscle hypertrophy. And in this case, it's hard to say what is driving those responses that we're talking about here. It's a myriad of factors, even when we're considering the biomarkers. So to really uncover what's happening, and this, if I can just back up for a second, Dr. Ormsbee has talked about some preclinical work today in animal models. And then we are talking, about, hey, he's got all of these blood in the freezer. Let me know. I can send some of my students up to you if you need somebody to analyze it. And I think that's what they're there for. And if we're going to be able to analyze those markers in humans. But this is why some of this preclinical work is important. To be able to go deeper into some of these mechanisms, especially on a molecular level, and then develop a rationale for what we're going to be able to look at in humans, and then ultimately determine some causative relationships. So for everybody that's listening, that's hearing, hey, this was done in an animal model or so forth, that's not evidence to say, hey, this is what's going to hold true. We know that does not happen all of the time, but it is a necessary step in the process, especially in something like this, where we just can't pinpoint what's going on. And even if we're able to analyze some of the blood that you have and you find some of these relationships, all they are just relationships. And then we have to go a bit deeper with some of that preclinical work starting out to then get back to humans to determine ultimately what the causative factor is. So your bottom line, a lot of things at play.
And I love that what's neat about here at the Institute of Sports Sciences and Medicine is stone's throw away, or, I could probably hit a 9-iron real well and hit the building that does the animal work. And so we have the ability to collaborate with people that can answer questions like that, because that's not in my wheelhouse, but it is nice to sort of team up on what tissues we could share, what blood, what we can learn from each other in these. But I'm going to go back to it. Like, I love the mechanistic piece because I love it, but the part that people care about has already been done. The proof is in the pudding. The data for training studies that include particularly multimodal exercise tend to be strongest for fat loss and keeping it off, particularly in sub-Q and visceral. Like at both depots, you're seeing a better outcome from multimodal exercise. But it seems like to me that there's a definite pattern where if you are neglecting resistance training, you're neglecting a major piece of that fat loss armory that you're trying to build. And so, like, I remember, like, someone once told me, you don't win gold medals with PGC1 alpha. Like, the mechanism is interesting, but the outcome is what we're going for, and we know it works. So why not? But I will tamper that a little bit, because just like I probably used to hype up protein is my favorite. It's a lot of people's favorites, macro, but I probably hyped it up too much at one point where it was like, eat this, you're going to add muscle. It's like, yeah, but you got to train. Like, the training is the stimulus. This adds a little bit more if you care about a little bit more. And so from a muscle building perspective, that's the case. There's data like Stu's group and others have shown that stuff. But on the fat loss side, I think we still have a lot to learn, because a lot of times when you're focused on resistance training, you're just not looking at lipolysis. It's like an outcome, like, hey, body comp improved. It's not what, why, how, when. And so that's why I think we have sort of a unique lane in this space that we've been playing in for some time. But it is just, one lane of the things we do, which just makes it fun. I love what I get to do each day.
Two super quick things. One, the outcome is absolutely the most important, and I think that is just so well said. And then two, how far are you hitting that 9-iron? About 140? How far away is that building?
Wasn't born yesterday, Mike. Yeah, man, I'm lucky to play twice a year. So if I'm hitting at 140 and it's straight, I'm taking it.
All right, there we go.
Amazing. This might be, it's definitely in the same realm, but it may be something that is not in your wheelhouse. So feel free to speculate or not to your heart's content on this. There's been actually a smattering over the last couple decades of interest in the topic of site-specific fat loss, or as we're interested in the fitness industry, how do I you get the person that comes up to you when you're still a personal trainer, or at Thanksgiving, and they go, how do I get rid of these? Or I want to burn here. So spot reduction is something that everybody wants. And, the typical card-carrying, evidence-based fitness professional response is that's not a thing. If it was, it's in, far too small of a, dude. And there's some anecdotes that you could throw out where you'd think, people who are constantly moving this given muscle or doing this in manual labor, you'd expect them to be a little bit different, or why don't tennis players have one shredded arm or something like that? I've said many of these things over the years, but there's been several studies now that have indicated there might be something going on there. Given you're actually doing, microprobes into specific tissue during exercise, I wonder if this is something that has kind of come across your lane or you've thought about, and if you have anything going on there, because obviously there's clearly some upregulation of systemic responses that could improve lipolysis. But what about some of the local responses that might be, tissues talking to one another in more of an autocomparison kind of sense? Like, is there, we talked about intramuscular triglyceride, we talked about overall fat loss, but what about like adjacent adipose tissue?
Yeah. So we've thought about that a lot because we have the tools to be able to do it and actually look at it. And we have the probes that can be simultaneously in the muscle and the tissue right above it in the fat. And so you could actually do those studies. It does get if you're in the muscle, it's a little tricky to do exercise with the probe in. We've tried that several different ways. It just gets tricky. It's a little bit harder to pull off, and the people are less willing to sign up for anything in the muscle. So we're always battling that. But one time a company approached us that had like one of these like electronic belts you're supposed to wear to burn belly fat. And I was like, let's throw some probes in there and let's just see, let's see what's happening. And once you tell a company like that what it costs to run a research study they run for the hills. So we never were actually able to pull that study off. So I don't know, man. It's definitely not something we've particularly measured. I'm aware of those new studies. I love how science evolves. Theoretically, it's got to be possible because, if you think about it in reverse, you can grow one muscle part. And if I think about an exercise that's very specific to an area, it's working something local, but there are also systemic factors that sort of help. Like if you do someone's in a cast, you bring them back and this arm makes this arm grow. There's things circulating that are helping these areas. So short answer is I got no idea. The long answer is I think it's possible. There's plenty of circumstantial things to show that it should work in some ways, but we haven't measured those. And those new studies are, I guess, promising because if someone has a real stubborn area, then maybe we can figure out exactly why. But again, if I go back to big training studies, I think you're in one of these cases where you're, picking up pebbles and missing the stones, trying to think about what's on the back of your arm. Jeez, let's do some full body exercise here and get a bigger bang for our buck.
For sure. Yeah, I think it's one of those things that is mechanistically interesting to the point that we just made previously, but practically the relevance is, it's very debatable. And I think we're probably more interested in things like targeting visceral fat and other things that are probably more indicative of potentially health status or metabolic status. So I think that's super cool and very interesting. So I think we're in a very interesting time now where we do need to be aware that even though we're interested in outcomes, some of the narratives we craft around the methods used to get to those outcomes is sometimes leading us to do things that are suboptimal. And as we understand what is going on proverbially under the hood, it can sometimes change practice because of the prior assumptions we had of what's going on. And I think a great example of this that is very close to, say, for example, fat utilization during exercise is the typical narrative we had around glycogen. So we didn't previously have, we being science, the ability to look at subcellular depots of glycogen utilization back when the first work was being done, 80s, 90s, 2000s. And I think the prevailing wisdom was, listen, you're not getting much more than a 25 to 35% reduction in glycogen from resistance training. You still got 3/4 of the tank or 2/3 of the tank left, which is absolutely not actually the way the body works. And there's signals that go on once glycogen is depleted to a certain point. But in more recent times, now that we've been able to actually do biopsies and look at specific subcellular regions of glycogen depletion, there's research that have come out of, I think there's a Scandinavian group, where relatively low volume powerlifting style protocol total glycogen depletion matches exactly all the research from prior decades, but the contractile specific depot of glycogen in fast twitch fibers almost completely depleted. And it makes you think, well, hold on. Like powerlifters have been saying forever, like, oh, I got the CNS fatigue. When I go heavy, and I'm not too sore. I'm not sure what's going on, but I'm having a bad day on strength the next day, or I just don't have it. And I think we don't even fully understand fatigue. But as soon as I saw that paper come out, I was going, maybe there is something to carbohydrate intake in strength and power athletes if we're thinking about not just total fuel utilization or even carbohydrate specific fuel utilization or even muscle glycogen, but if we're talking about the specific depletion of glycogen that is actually enabling us to recruit and utilize the fibers that are directly producing the work we care about, that's interesting. And I think it tempered some of the, I'd say, low-carb enthusiasm, or that this is totally okay. And it's not that we can't look at a study where you give powerlifters a ketogenic diet and they're fine and not use that. We absolutely should. But when we're starting to think about what could be going on, how would I sequence my training, when would I do high volume, when would I do low volume, and how might I eat in relation to that, I think it gives pause. And it should, right? As we understand a new mechanism or a better mechanistic understanding of what's going on under the hood, it opens new avenues for applied studies because we have a hypothesis to chase down to see if it matters. So I guess the question I have for you, Mike, is regarding some of the interplay between glycogen and fat utilization. I think people tend to think that you're using one or the other, but the research that we do have in resistance training indicates you're using a fair bit of both. And do you think that's happening acutely, or is that kind of more the chronic effect?
Yeah, another good question. Yeah, I think you're using a fair bit. So listen, we've got plasma, intramuscular fat, and stored fat that we can access here. And we know in many different studies that if you're looking at exercise intensity, for most people that eat sort of a normal Western diet to some extent, you're going to have 65% of your effort where you're using about half from intramuscular triglycerols and half from plasma fatty acids. So that's that sort of zone. Now, different dietary structures will shift that left or right, on the scale. But the interplay between glycogen depletion it just makes sense to me that then obviously you're working on this crossover concept to then hit the fat ox portion of it. I don't know enough about the timeline to know that you were talking about this, but we do know acutely that that's happening as soon as you hit a certain point with aerobic exercise, you get that cut off. And there's data in resistance training that will probably make that pretty close. My biggest take from all of that is I think we overcomplicate the heck out of ex-phys and nutrition. And when I'm working with any clients, I still maintain one or two actual clients. It's a place where I always emphasize, first of all, how do you feel? And then we'll move to, do we need any more nuance to sort of push the dial either way for whatever the goal is on that specific time? And sometimes I'm manipulating carbohydrates, and sometimes I'm manipulating different types of exercises in that range. But I guess the short answer is I'm not really sure. And that's what's needed. For example, we'll look at the mechanistic piece, and we have receptors all over the cell for these different things. And we're looking at two of them.
Yeah.
Not to mention the drive of insulin here. And not to say you can definitely lose body fat when there's insulin around, look at these GLP-1s, right? So there's something going on here, but there's just so much to it. And I think that's a job for us to figure out as scientists, the nuanced piece of it. And I think we just do the best we can in terms of the advice we give based on, yes, the science and evidence led for sure, but we can't neglect the case studies. We can't neglect the N of one. We can't neglect how somebody's feeling, because that's real. And that's how that person feels about something. So I love taking all this science and sort of trying to make a recommendation, but at the end of the day, it's if you don't like to eat carbohydrates, then I'm not going to force you to eat carbohydrates. Let's figure out another solution, to make that work, or vice versa.
That's well said. That's well said. I think it's an exciting thing that there is so much less left to uncover, because it means there's more work to be done and there's better understanding to have. And I think while there's a lot of people who are attracted to science because they want definitive answers, the real scientists love science because it generates more questions. And it is the curiosity that spurs the future. So I guess my next question for you, since we are curious about this, we have so many questions to answer. What is some of the work that you're doing in the future in this area that you're excited about that you can share with the audiences, what they might be learning in the coming months and years?
Yeah, so I talked about the big study we're working on now. So that's the one that we're 4 or 5 years into figuring out what's happening with this particular group of with obesity and postmenopausal pre-diabetic women, which is a very specific group and doesn't appeal to all the listeners, of course, that you've got. But some of the takeaways will be consistent with at least what's happening with this mechanistic piece. But one of the things that we've done in our studies along this whole journey I've been discussing is including protein feedings in and around training and throughout the day and even late in the evening. And so one of the studies where we had the best benefit, I already described it, where we had this reduction in everybody won from aerobic or resistance training. But if you did the resistance training and a higher protein diet, you had far better outcomes. And so we sort of dug into that lane. And we didn't design that study to be a pre-sleep feeding study, but it turns out that's what we did. And then when we look back, we're like, okay, those people had the best outcomes and they were eating before bed. And that predated our first pre-sleep feeding study by 8 years. And so we finally came around to like using those earlier data. And then my first projects here, when I got to Florida State University in 2010, were looking at specifically that little piece from that other study that's now in pre-sleep feeding. And so that's a whole lane that I think is exciting. We have many studies in this space as well. We're looking at nutrient timing, but particularly that period of time that's 2 hours after dinner and 30 minutes before bed. And that's really important because today you hear people all still, and the reason we did this was there was a show on at the time called Biggest Loser, and everybody said, stop eating at 6 o'clock or stop eating at 7 o'clock at night. Like never eat beyond that time. There wasn't like a ton in like circadian biology that was in our space of like XPhys and performance nutrition yet. And I was looking around at athletes that I knew and myself, I was always eating. And some of the leanest people I've ever met are these bodybuilders who wake up in the middle of the night and drink a shake or eat a steak or whatever they're doing. And like, there's got to be something here. And there was like basically no data that existed at that time. And how we were defining it. It was clear why people were worried. One is people were worried because like that there were like earlier data where if you gave, it was roughly 500 calories in the morning, in the middle of the afternoon, or late at night, you sort of handled those calories worse at night. And you just basically your energy expenditure from that meal, your thermic effect of food was significantly lower if you had that late at night. And so people are like, all right, well, don't eat at night. We should do this differently with a little bit with like the circadian things like metabolism, glucose tolerance, gastric emptying. Those were things people were worried about. And I remember here like one of the biggest tips I ever got, and it was like a accelerator for my career, was we just started in this lane, and I found out that Luc Van Loon was also doing some work in this lane. We were in applied outcomes, metabolism, and Luke was doing muscle protein synthesis. And so I saw him at American College of Sports Medicine, and I thought, I'm never going to get on the stage if I don't team up with someone who's on the stage. And so and Luke was so gracious. I said, hey man, you want to go after a symposium together next year? And he's like, I'm in. So that was so cool to get to work with him. I'd read his work for ages, and then because we were on that topic, it sort of accelerated where we were going with pre-sleep feeding. That's sort of besides the point, but it did show the interest. And for about 10 years, we were the only 2 labs really working in that space. Now it's pretty fun. I mean, every other week I'm finding a new paper someone else did that I've never heard of in the space. And it's really accelerating how fast we're learning about this area. It helps me with study design. It helps me learn sort of where we need to go next. And almost all of it I learned from mistakes I made in my early studies. And then we did the next study, and then we made a mistake and we did the next study. And so we've done like, a ton of this over the last 15 years. So we can go anywhere you want in that sort of conversation.
Mike, there's a lot there. And I have questions for you about pre-sleep protein feeding. The one thing you just said there, I think for everybody listening, is regarding, well, really two things. One, mistakes you made in earlier studies. And then two, you talked about the current project you have going on being in its 4th or 5th year. This, if I'm correct, this is your R01 funded project, correct?
Yeah.
So for everybody out there, one, to be a PI on an R01 is a big deal. And two, it just shows how long and intensive some of this research takes. So whenever we're saying, hey, this study should have done this study should have done this, it's not all. Sometimes the researchers didn't know, but sometimes they wish they could have done it too. But to understand really what goes into this, it's extraordinary. But then when you say mistakes that you've made in previous studies, it's such a beautiful thing in a way, because there's so many mistakes that I've made in previous studies and still do to this day. And the only thing that you learn, or the only way that you learn is by looking back and being critical of your own work and realizing, I didn't know this at the time. This paper has come out since. I have a paper I published in 2016. We think we collected that data in 2014. And everybody always asks me, is a resistance training study, well, what were the difference in repetitions and observed between the two groups? Was there a difference in proximity to failure? And I say, I agree with you, but I did that in 2014, and I didn't publish the paper on the RP scale until 2016. I wasn't thinking about that at the time. And so the fact that you have that, you see that, and you connect with kind of one of the big dogs as you did at ACSM, and to be able to learn from that work. And so for everybody out there, that's really what births so much research and so much improvement in research is scientists like Mike looking and watching other research and understanding how they can improve their own and being critical of their own. There's some things now that I did years ago, and I'm like, man, I kind of want to write a letter to the editor on my own paper. And just say, listen, I the way that they did this here, or so forth, and that sort of thing. But you learn and you get through that. So I think it's really awesome on the pre-sleep protein feeding. And I remember when you were first getting started in this area and reading some of the early papers that you had on it. There's so many ways to go with this, whether it's and I kind of see where you want to start with it, but it's when you're having this pre-sleep feeding, is there, the old bodybuilder magazine debate of whey versus casein, right? Is one of those superior to the other? And then for what purpose? Is fuel utilization different in the morning when with protein versus not having protein? Is performance different in the morning? Are there long-term longitudinal benefits of this? And are those for hypertrophy or strength or for fat loss, right? So there's so many different facets of this. And I think that's important as well, because we often just think, hey, pre-sleep protein, what's that going to do for, muscle growth? And that's only one question. That's a different question than strength. That's a different question than acute performance. That's a different question than fuel utilization the next day. That's just a different question than potentially the next day self-regulation ability of somebody because they had protein before bed. So I don't know where you want to start there because I'm not as familiar with the data with you, but those are all of the things that I think of under that umbrella.
Yeah, there's so many ways to go. What I knew to stay out of MPS because Luke's got that covered. And we would have Lauren here to really get good ideas. For sure. She's our wristed out of that. I mean,
Yeah. I always say, like, I worked under Dr. Kim on animal models, but not really. Lauren's the real bench scientist of the group.
Nice. Yeah. So that was kind of where we're at. Okay. What do we know? What are we good at? And we're an applied phys lab. So we start with very applied. And if you look at those early studies, they were pretty darn applied. Like sometimes if I say basic, you think I'm doing like benchtop stuff. I mean, like they were just basic studies. Like we didn't have many tools. We were simply giving someone casein, carbohydrate, whey, or placebo. They went home, they drank the shake before bed. I trusted that they drank it. They came back into my lab in the morning. We measured resting metabolic rate with a ventilated hood, and we simply reported the energy expenditure they were having at the time to say, what does that do? Did it do anything? And so, those really early ones were based off of that. And because we were sort of piggybacking this off the idea of weight gain, body comp, that was the initial intention that we got into it for. I wanted to see, did it do anything to our metabolism, which then could possibly affect overall weight gain, weight maintenance, body composition, etc. And so there was an initial study, the first one I ever saw, that fed like a snack after dinner, because there's a lot with like huge meals before dinner, as I kind of described. Not a lot, but a good amount. And the smaller meal theory came out like in 2004, they gave individuals the chance to eat a cereal, like a bowl of cereal after dinner. And they did that over 4 weeks. It was like 90 minutes after dinner, they were able to have a bowl of cereal. And it turned out that the group who got the cereal had better outcomes in terms of weight loss, weight management, and all this stuff. And the hypothesis was maybe that's because if you can have a small bowl of cereal later, you might not have double servings of dinner now. And so your trade-off is better in overall calorie maintenance. And they didn't describe it all that well. But it was a place to get started with, like, what is happening in this little space. And then we also knew that with like studies with higher protein intakes, if you measured your sleeping metabolic rate, those who have a higher protein habitual diet sort of rev higher while they're asleep all night. And so those two things, I was like, all right, well, let's just check what happens here. And we had several students get involved over the years. I mean, they've been so good at carrying these studies out for us. And we gave this whey, casein, placebo, or carbohydrate, calorie matched except for the placebo. And in our very first studies, if you had carbs, casein, or whey, you had an increased energy expenditure some 8 hours later in the morning versus having the placebo. So eating anything before bed still had people a little bit higher in the energy expenditure piece than the placebo. So like, okay, well, that's kind of interesting. And then we looked at RQ from those studies, and we're like, all right, what's going on with fat oxidation? And the placebo and the casein were both lowest on the RQ scale, indicating a greater fat oxidation, not by much. I mean, very small, but statistically significant than a carbohydrate or a whey. And so at that point, we're like, all right, casein looks like the one I would be choosing for this particular outcome. And we also were using casein because it was, in the daytime studies looking at peak in muscle protein synthesis and stuff, was just like an extended release amino acid drink that we thought would be good for nighttime because it would sort of drip into the blood all night long. And it turns out that was kind of debunked on the muscle protein synthesis side more recently, where whey and casein had basically no difference at all. Like, choose which one you want for muscle protein synthesis overnight. So kind of cut to the chase with that one. But we chased the casein story for another several years because we didn't have that data yet. So we thought casein was the way. Casein was the protein to use in that space. And we also measured satiation. So like in the morning, if you had the casein, well, no matter what you had, if you had food, you felt more satiated in the morning than a placebo. But casein seemed to have sort of the greatest magnitude of change. So like, all right, well, that's kind of a win. But then we thought, wait, is that good or bad? Like, if you're not hungry in the morning, is that good for weight maintenance, or is it bad because now you're not eating breakfast and that's supposed to be an important thing to think about? So we started trying to figure out what exactly was happening with that. And we ended up running, after those acute studies, our first 4-week training study. And we did it for two reasons. One is that when we did it acutely, in this particular study, we used overweight women. And when they ingested anything before bed, a carbohydrate or a protein, they had worse outcomes for glucose and insulin in the morning. And we said, well, that's not a good thing. We don't want to be dealing with that. So as we thought to ourselves, we're like, well, let's add exercise. Let's just see if exercise sort of ameliorates that response we had to glucose and insulin. And it did. Just 4 weeks of resistance training got rid of that glucose response that we were seeing. So it was kind of trending the wrong way. It was not, if I saw it, I wouldn't give it to my family member to do because I'd be like, I don't know. we did exercise training and it sort of got rid of that. And we also looked at fat mass changes, and we looked at, we had to do it as a percent change because it was like very, the data, you have to look at it in a way that's like something people will resonate with. And it's not moving statistically, but when I look at if the bar is going down, indicating fat loss, or bar is going up, indicating fat gain, if you had whey or casein, the bar was down. There was something happening. It wasn't statistically significant, but something was moving the needle to be maybe a fat loss aid in these early studies. That was a 4-week study with it. And then here's where we had the problem. Like, we found out, or we started thinking, and we had reviewers, honestly, that were like, you don't know if they drank it. They're driving into the lab. You don't know if they got like a car accident on the way in that jacked up their energy expenditure. Your stuff stinks. Retire. I was like, well, let's try to make it better. So we started at that point setting up sleeping arrangement in the lab. So we brought in cots and we brought in all this stuff to make it a good environment. And we even started adding microdialysis because I wanted to know what was going on with lipolysis while they were asleep. What was going on with glucose? What was going on with insulin? What was going on with the glycerol? And so we got a little bit more mechanistic with it over time. And so we started, again, like blocking certain receptors, activating certain receptors, trying to see the whole picture. And Amber Kinsey was my first doctoral student some 10 years ago when she finished. And we had probes overnight in overweight men, and they would go home and sleep with the probes in. So we had really cool data. And I'll never forget it. She came in my office and she's like, I just ran all the data. There's no difference in lipolysis if they had casein or if they had a placebo. My whole dissertation's screwed. Like, what am I going to do? I'm like, wait, no, it could be a good thing. What we're seeing is that people have an option to consume some calories before bed if they're hungry, and it does nothing to lipolysis or fat oxidation, which means it's a chance to increase total daily protein intake. If we did this outside of an acute setting and over longer term, maybe we would see beneficial results. And so when we looked at it that way, it was like, okay, people have an option, and it doesn't do anything to lipolysis, at least in that one study. And so, we followed that and we said, well, we got to repeat that. Let's see what happens. And and then I had like Brittany Allman in my lab, and she was into lifting, and we decided to repeat portions of studies we had done in men a long time ago for resistance training and fat metabolism, like we were talking about. But we also added in a piece where we gave a workout, and after the workout, you got a placebo or a protein drink. And if you're in the other group, before bed, you got the opposite thing, the placebo or the protein drink. So protein was matched, but you got it at a different time of day. And when we did that, we had great responses from resistance training, increasing lipolysis. So that was cool. The protein at whatever time made no difference at all in the outcome of lipolysis. So once again, we're showing that you have an option before bed, doesn't change lipolysis, and it didn't change anything else in our short, study here with when to take it. And we've done more work on this. Alex did a version of this for his dissertation where Dr. Kim ran it, but it was very similar design, except it was longitudinal instead of an acute. And he did this in older men. I'm forgetting I think everybody was over 60 in that study.
Yeah.
And in that particular study, no matter when you took the protein, there were no differences in functional outcomes over time, as long as you got the protein. And the one thing we didn't have was a group who did not do that. Everybody got the extra protein. So what we probably should have done was have a group that didn't train, a group that didn't get protein, and like went the length of it. But what it showed us was once again, like probably the most important piece to this in this context is that it's increasing total daily protein intake. That's usually a good thing for most people. And if you have it at a certain time of night, it looks like it's not going to change lipolysis if you take it before bed. And people don't need to be scared of having a protein-dominant snack before sleeping in terms of gaining fat. We've not seen that yet in any of our studies. And so like that was kind of the way the literature existed for quite some time in our space. We've tried other things like semi-solids, because we were given shakes. These were all protein shakes. Like one time we went to the supermarket, we got a jug of cottage cheese. And then I sent that cottage cheese to a manufacturer to powder the exact same macronutrients. So then I had semi-solid versus a liquid versus a placebo. And we looked at all the same sort of very applied outcomes, energy expenditure, RQ, et cetera. And we saw no difference in terms of any of that across the board. But every single woman in that study was over 1.75 grams per kg of protein. So the highest, if we had different protein intakes, I'm sure would have a different outcome, but they all had very high protein intakes by taking this. And then the placebo time through, they already had a habitually high diet because they were trained women. So we probably made a mistake there too, and who we recruited for that study. Although we thought we made the right choice because those are the people interested in eating before bed in that particular one. So, we keep learning along the way. And the biggest thing now, if we're interested in like where it's going, is, well, let me first say what happened in the muscle protein synthesis side. This is not our work, all of like Jorn Tromelin and Luc Van Loon's work and their colleagues. But they saw great results in terms of overnight muscle protein synthesis with early intakes of casein drinks. They did like nasogastric tubing in some of these studies. They use like a traced milk, so it's actually from consumption. It's just a phenomenal laboratory setup. I'd love to see it someday, but they're showing improvement in overnight muscle protein synthesis. Probably the most important piece of that is that they're finding 40 grams is the ideal dose. They gave 30, they've given 20, they've given 20 plus 2 grams of leucine, they've given 30 plus 2 grams of leucine. And all of those things, 40 seems to be the winner simply because, well, what they say is it's because it's such a long period of time. Like you've got it 7-8 hours of time. When you do these studies during the day, you're looking at like a 4-hour window that typically people measure muscle protein synthesis, and they're measuring over 8 hours. So it's just a long period of time. So, and then they had one study from Snyder's that showed a functional outcome where, again, I think it was maybe 16 weeks of training, and every night they had a pre-sleep protein drink, or the other group had a placebo. And the group who had the pre-sleep protein dominant drink had better outcomes, bigger cross-sectional area at the end of the study, better strength outcomes. But when they looked at the group's intake, it was 1.9 grams per kg of protein versus 1.3. And so they simply used the pre-sleep feeding as a time of day by which you're usually home, have access to protein, and can get an extra feeding in. So those are big wins across the board, to just use that time to get the extra dose in, to bump it from 1.3 to 1.9, let's say, and then have these functional outcomes that were really interesting. So that was kind of the whole state of everything. And then those darn reviewers again started getting all over us for, we didn't measure sleep appropriately. And I never even thought about sleep. Like the beginning studies, I wasn't even on my radar at all. So it turns out we started adding in like a question. Hey, Eric, did you sleep okay last night? And you're like, yeah, I slept fine. I'm like, okay, well, you're 25. You're going to sleep fine no matter what. And then we're like, we probably should get more sophisticated. So we did some more questionnaires like the Pittsburgh Sleep Quality Index or something. And there's some athlete versions of it too that we started to use. And we were showing like no difference in sleep. And I'll tell you, it was interesting because when they slept in the lab, we were worried their sleep quality would go down just from that. And then we had to do it at home just as like a baseline tool. And it in our data that those, even though this it sounds weird, the situation was not different. Their sleep wasn't different in terms of a questionnaire. And then we're like, let's use some technology. So we started using wearables. We used fatigue science one time. We used actigraphy several times. We started working with Whoop. We started working with just recently like Absolute Rest and getting some more information about these sleep habits. And so never before in this specific space has someone designed a study with the outcome of sleep. It's usually been something else, muscle protein synthesis, fat loss, RMR, what have you. And so we're looking at that now. We're wrapping up a study where we're looked at female athletes specifically, 3 consecutive nights of a protein feeding. And we're using these novel proteins that are, well, they're novel to this space. So alpha-lactalbumin is a derivative of whey. It's high in tryptophan. It's new to like selling to adults, but it's an infant formula because it's in mother's milk naturally. And so it's been isolated and put into a bottle. And there's been 2 studies in rugby players. Actually, I think one was in New Zealand, and they showed a benefit to sleep onset latency by having specifically alpha-lactalbumin before sleep. So what we're doing is trying to repeat it in our lab. So we're doing alpha-lac, and we're also doing a whey hydrolysate, a whey isolate, a casein, and a placebo, multiple different treatments over time. We just finished data collection, so we're starting to wrap up or organize everything for analysis. So we should have some information on the sleep front. But I will say, sleep is something that's real interesting. It's everybody's like, oh, it messes up sleep. Even the big companies that sell these wearables post a lot about not eating before bed. It improves recovery. It puts you in the green score, makes you ready to do activity. And, against my better judgment, I get trapped into commenting on that stuff sometimes. And I'm like, when, why, who, what's the population we're talking about? If you're an athlete, you have a game at night and you compete again tomorrow morning, you better eat something. So context is pretty critical, in this space. So you just got a whole earful of pre-sleep feeding in my long elevator ride.
No, it's perfect. And I can tell you that you actually covered the 3 key points that most people in, say, the bodybuilding space are really interested in related to protein feeding at night. Is 1, if the protein is matched, so we're only manipulating timing, will I get a benefit? And while there's still more work to be done, because we've had a lot of studies that haven't looked at longitudinal outcomes while matching protein intake, like you said, Schneider's, there was a 0.6 gram per kilogram difference. Right now, it's looking like it's a great opportunity, but it may not necessarily enhance outcomes. And then people go, okay, but is there a potential downside? And the old school concern is, all right, well, eating at night, is that going to have a negative impact on body composition because, thermic effect of feeding, or, negative impact on satiety, or one of those other things? And from what we can see in both applied and mechanistic data that has been done, you're probably, if you're just consuming a protein-dominant meal, not going to be worse for wear in terms of a body composition outcome. And then the more recent one is there's been more interest in circadian rhythm, the impact of eating before bed, is okay, but I know sleep is really important. So is having one of these, anything, even if it doesn't necessarily change my body composition, is it going to indirectly cause me issues because it's disrupting my sleep? And it sounds like more work needs to be done there, but at least preliminarily, it seems like something along the lines of 200 calories at most of a protein-dominant meal before bed doesn't seem to have any kind of systematic, clearly negative effect on sleep. Is that an accurate summary, Dr. Ormsbee?
Yeah, absolutely. And in that sleep piece, like even Luke's group has published some tables in their more recent papers on sleep and showing no difference either. And there's some athlete data, like in Falkenberg had a paper that was more, I think it was Australian League football, and they were showing protein actually improves sleep outcomes before bed. And it was real nuanced into what they were eating. Diet logs are what they are. But there's not a strong case, in my opinion, that if you're looking at a protein dominant snack before bed, you're going to have any problem with your sleep outcomes. But that's why we're measuring it. That's how we're studying this stuff. And so you hit all those big areas right away. I'd say the other 2 big areas that we're moving into, because we just don't know, probably 3 areas. The biggest question we get now is there like a calorie cutoff by which it goes from not doing anything or being helpful to being negative? So is there like a threshold? We don't know that answer. Quality of the food you're eating. Does that make a difference? So those are 2 areas we've got grants in now to try to explore. Individual nutrients or micronutrients. And there's some data around magnesium, omegas, this kind of thing. What about whole foods? For example, some nuts and seeds and stuff have some nutrients that could be beneficial. Like, for example, pistachios might be beneficial, but there's not a lot of data there. So we have a grant in with those guys to try to figure out these types of foods. And then the last bit is for totally unrelated, the specific nutrient, but in certain populations, like military personnel, ROTC, and these folks, a lot of times you're finding in men and women, low energy availability, lower carbohydrate intake than you might expect. Protein seems to be okay. And one of my students is interested, I only she's just brought all this to my attention, but we may try to work it where we give like a carbohydrate and protein supplement so that we can bring them into an area that's good, and then look at what's happening with sleep as sort of a secondary outcome in those studies.
Fascinating. I can speak for probably Dr. Zourdos as well, but I'm really excited to see the future work that's coming out of your lab and others that you've talked about. I think the last thing I have to say, unless you've got anything else, Dr. Z, is I just want to say thank you for not only the work you do, but the work that you are continuing to do, and for giving us your time, and not only talking through fat oxidation, fat utilization, and potential body composition changes related to resistance training that might surprise people, but for those who hung on past to the hour-long mark, they got the deep cut for the pre-sleep protein feeding kind of bonus episode. So just a huge thanks for that. Dr. Z, anything else you want to add?
Just briefly on sleep quality and maybe macronutrient distribution broader. Dr. Helms wrote, we wrote about sleep and mass a month or two ago. We wrote one of our quick take summaries, and I think you and I both contributed substantially to this. I think I drafted the original version, and then you cleaned up my mess. I was originally going to include a section in there. I was including sleep hygiene and things like that, and I was going to include a section potentially on macronutrient breakdown in sleep. But I commented to you, I think it's done. I don't feel confident after I got into the literature including anything on macronutrient distribution in sleep, because there were some older articles that told a different picture than some newer papers that were out there. And I just didn't feel comfortable making any claims or recommendations about that. And then, of course, there's one of the studies I think Dr. Ormsbee was referring to is from Ferguson et al., which I think the good Dr. Trexler did review in the Mass Research Review not too long ago. And it was also concluded that the low dosage of tryptophan that was in there did not have any effect on sleep either. And again, that was a low dosage. But so I am excited to see what you do, man, because it's very possible that some sort of macronutrient distribution, even if extreme, has an impact on sleep. And that's how a lot of proof of concept things work, right? Something is done to the extreme in kind of the initial phase of that research. Then we find out later when there's maybe a little bit more of this thing, but not a lot more. It's just not that big of a deal, and we don't have to worry about it. So I'm not sure exactly what you have planned, and hopefully some of those grants are funded. But I'll be interested to see, because that's a topic that I tried to look into recently and just felt I could not make any definitive claims on, and there is much work to be done out there. Other than that, Dr. Ormsbee, it is an absolute honor to have you on here. For everybody listening, this is someone that I truly consider a mentor and admire and look up to, as a researcher, but, as a person, and just appreciate the time to come and help us out with this thing that we do.
You guys are most welcome. Eric, Mike, appreciate the time. And I think there's lots of ideas rolling around. So if we get some good ideas to make a nice collaboration, let me know.
We think in multi-site data collection, because that's where the grants get funded these days.
Yeah, I'm thinking your access to bodybuilders specifically, because I'd love to know if waking up to drink a shake is different than going to bed with it beforehand on longitudinal outcomes.
My hypothesis is waking up in the middle of the night to eat is probably not the greatest idea in the world in the grand scheme, but I'm absolutely willing to test it if I can find the psychotic folks willing to do it, aka other people like me. And I can tell you, absolutely, it'll probably take a multi-site data collection to do it, because we're probably, fortunately, few and far between spread across the world as bodybuilder types. But no, huge thank you for coming on. Lots of good work to do. I know at the very least, we'll be reviewing your work in future issues of Mass as it comes out, because it's right on target with what people are interested in. And maybe there are even actually collaborations that we can do across our labs, which I think would be really cool. So no, I just want to echo Dr. Zourdos. It's been a pleasure and a privilege to finally meet you in person. I know we've communicated via email a little bit previously. Thank you for sharing your wisdom, experience, thoughts, and humility, which I think is a great thing for people to see as a scientist. And for all of those listening, thank you for tuning in. This has been a pre-recorded episode of Iron Culture presented by Mass. So that means you did not get to see us live this week, but we're going to be probably back next week live, although we do have some other pre-recorded episodes. So I'm telling you all this information. I'm basically saying, I don't know, but you're going to hear something on Wednesday or Monday or both. I don't know, whenever it comes out. If you're listening on a podcast feed, give us a second, take some time, write a review. If it's positive, if it's not, don't. Give us a 5-star, and also help us out. If you want to support our ability to do these free podcasts, please consider subscribing to Mass. Think about how much more depth you can get out of some of this information when it's supported by our written work, our videos, our audio summaries, our training guides. So much. We'd love to see you in there, and we'll see you next time on the next episode of Iron Culture presented by Mass.